Okay, so this is the vacation survey information. And what we want to do is we want to do a hypothesis test to see if the average age is going to be 35. Now, for the single sample test, if you look in the data, you'll notice the data analysis doesn't have it. It only has um, the two sample test. So we have to do this manually. Now, luckily, there's actually some templates with the book. So if we're doing a z-test with where we actually know the population standard deviation or we assume it, then we use this template. But for most kind of applications, we just want to use the t-test. And in fact, that's the standard one for the chapter. So for this video, I'm really just going to focus on the implementation in Excel. And then, we could have some additional videos or some kind of question and answer sessions to go through the theory a little bit more if people are struggling. So let's do is we're going to copy this template. Just make sure I had it on H. We're going to copy it over to our data. So the idea is we have a template here for running these tests, and we're just going to put it on the same as the data. Now, the template has a few things. It has your actual calculated t-statistic. It has the rejection value if you're doing a one-tailed test, and it has the rejection value if you're doing a two-tailed test. So the two-tailed test, because the type 1 error is kind of just equally distributed in both tails, and this tends to be a stricter test. And then it will actually give you the results for the lower one-tailed, the upper one-tailed, and the two-tailed tests. So just to kind of quickly record the two-tailed test, where basically our null hypothesis is always that the mean is equal to 35, and the alternative hypothesis is the mean is not equal to 35. But we can also do kind of two one-tailed tests. We could do a lower and the upper. So we could have H0 mu. Now, let me just get the alternative hypothesis first. So maybe we want to see if the mean is less than 35. Then the null hypothesis is it's not going to be less than 35. So then we could do the equivalent with the one-tailed upper. So that would be like this. And again, I can go through the kind of hand calculations in more detail. So these are the three tests. Basically, this one we're testing in both directions. We're trying to show that it's not equal to 35. This time we're trying to show that the mean is less than 35, and here we're trying to show that the mean is greater than 35. So those are our three test options that we're gonna test. So what this does is this will use the t.inverse function to actually do the one-tailed test. And this is just saying this is the level of significance. We're going to be 0.95 along the t-distribution. And we're going to have basically our sample size minus 1 degrees of freedom. The t-distribution has degrees of freedom. And then we're going to compare it with the t-statistic. But let's not focus too much on this, and let's just actually work out how you can do this. So first we want to we've got all these figures in here, and these are not specific to the examples. So what we're going to do is we're going to calculate the sample size. And that's just going to be equals count, and then the range of the data. So we have 34 vacationers. And then you can imagine going down, let's just kind of copy this. For the sample mean on the same data, it's going to be the average. And the sample step then we're going to do for the standard deviation, we're just going to do stdev. And of course, we're using the sample, again on A4 to 37. And we're trying to prove whether or not it's going to be 35. So that's going to be our hypothesized value. Now you see here my t-statistic is 2.72. My one-tailed t-value, this is my critical value, is going to be 1.69. And my two-tailed value is going to be 2.03. So let's just see what kind of conclusions we can make here. So let's just start off with the two-tailed test. So here the critical t-value is 2.03. My actual t-statistic is 2.72, so we're much bigger than this. So as we're greater than the critical value, we can reject the null hypothesis. Also note that our p-value is less than our alpha. What the nice thing about using a p-value is whatever kind of statistical test you're doing, the p-value is how far away we are, a measure of how far away we are from the null hypothesis. So if your p-value is less than alpha, then you reject. And in fact, in most computational statistical tests, we rarely mess around with the critical statistics. We just look at the p-value. P-value is less than the alpha, then we actually reject. So we have evidence here to reject the null hypothesis. Now again, the upper one-tailed test, because our sample mean is 39 and our hypothesized mean is 35. So we're obviously well above the hypothesized mean. So our upper one-tailed test, basically we have a critical t-value here of 1.7. And again, my t-statistic is 2.72. So we reject the null hypothesis. Now, the lower one-tailed test, we're actually going completely in the wrong direction here. So we don't reject the long, because we're testing, is this less than 35? Well, no, it's 39. It's greater than 35. So we actually here, we do not reject the null hypothesis. So again, when you do this in the homeworks, it's going to ask you for perhaps the p-value or the critical t-value, and you can work everything out from this template and just make sure that you actually, for each of these, you just basically put a count of the data for sample size, an average for the data for the sample mean, standard deviation.s for the standard deviation. Make sure you put in your hypothesized value, and this is the alpha or the strictness of the test. Note if, say, for example, I put alpha equals 0.01, we get a much stricter test. My two-tailed t-value now is 2.733, which is actually greater than my test t-value, so I no longer reject the two-tailed hypothesis test. So let's kind of go back to 0.05. And let's just kind of summarize the evidence on our little chart here. So let's use a pen. Let's use a red pen. So we have evidence, our X bar was, what was my X bar? Was 38.676. So my X bar was 38.676. And based on our t-values and our p-values, there's evidence that This is not 35. The one-tailed test is not as strict, so there's evidence it's greater than 35, but it's kind of common sense. There's no evidence that it's less than 35. So we're going to put a cross there. So we have evidence that for H1 on the two-tailed test and for the one-tailed test.